suggest. And so for us, you know, we've taken the risk out of the process. There's been a very extensive due diligence done by SMS Group. We've incorporated a German joint venture company called Primobius GmbH. We are co-funding the building of a demonstration plant at SMS's facility at Hilkenbach. We'll evaluate both a 20 and 200,000 tonne plant. SMS will be responsible for building and operating the plants and arranging debt on best endeavours basis. We've contributed our technology. SMS are essentially a 130-year-old engineering company, 14,500 employees at 95 sites around the world. They are one of the largest constructors of plants in the world. They are not there to build little 20,000 tonne plants. They are there to build very, very large plants to meet the needs of the market. So, you know, the Primobius is a validation, one, of our business model, two, of our technical flow sheet, three, the size of the opportunity. They agree with us. And, you know, we called the taglines battery recycling without limits, because essentially whatever is required in Europe or elsewhere around the world, they can build and operate the plants to match. And that's important, particularly in this COVID world. We're stuck down here in Australia. We can't travel anywhere. So it's fantastic that we've got good boots on the ground in Germany with these gentlemen. This is where we're going to put it. We're going to put it smack bang in the middle of Europe. This is their production headquarters. They've been there for 130 years. Essentially, we will take the cells from car makers and cell makers, process them safely, recover the high purity chemicals, give them back for them to evaluate in their supply chains. The demonstration plant, SMS are going to design and build that. We have, like I said, we've already procured a 20,000 tonne front end. That's in Germany as I speak. In terms of the scale, the demonstration plant will be at 1/24 the commercial scale. So it's a very, very small scale up to go to our initial 20,000 tonnes off the back end. And so like I said, we'll take the output and get that qualified. We'll use the opportunity also to run around some of the regulators and the pots of green money to try to get cheaper financing. In terms of our indicative timeline, we'll have completed the construction materially by the end of the year. We'll start in March, wind that up in June. We'll finish the Class 3 engineering cost study and look to make a final investment decision in the March quarter of 22. For the investors, you know, just the business case, the value proposition, and where we see the growth. You know, our aim is to be the recycler of choice for the big EU car makers and cell makers. We sized it off stage 1, 20,000 tonnes by taking the off-spec material in the production process. So off-spec cathodes, jelly rolls, failed cells, failed packs. And then, you know, we want to get into a relationship there with them to share in the benefits there, and to the big game is to capture the big volume at the end of life for the 90% that goes out the door and goes into cars. In terms of the economics, you know, this is a very modest size plant, taking a mixture of EV and consumer batteries. The operating costs put us down the bottom end of the cost curve with cobalt, excluding the byproducts. If you include the byproducts, it would be probably the lowest point on the cost curve. The capital cost is reasonably modest. We can meet our capital requirements off our balance sheet, very quick payback, very, very robust economics. So I think, you know, I tried today just to tell you about the business. You know, there's an incredible need for it. It's a massive market. We've developed a process that, you know, we have one of the world's largest construction or plant building companies had a very extensive due diligence, looked at it, says that's what we want to do. It'll meet the requirements for reducing CO2 levels. It'll meet the future requirements for mass recoveries when they do legislate. I mean, there's in some parts there's recycling legislated, but once they get to, you know, an 85 or 90% minimum, we'll see some of our competition drop away. You know, NeoMetals, I guess, as a group to make this happen, we've got a very, you know, we've got a fantastic balance sheet. We can fund this project off our balance sheet, you know, without resorting to external financing, although we will avail ourselves of it. There's a clear market cap discrepancy. You know, we've got a market cap of about $100 million. We've got more than $80 million in cash. This is just one of our projects, albeit the most advanced. Multiple catalysts across the portfolio. We've got a history of making money and giving it back. And this recycling business is really, you know, a lot of companies and a lot of miners will be talking the talk. We're actually walking the talk, and we've actually done a hard pivot towards materials recycling and recovery as a way to become a leading sustainable investment opportunity. So thank you very much for your attention, and happy to take any questions.
Chris, man, that was awesome. I mean, there you are. What is it now? 11:30 at night. You are suited and booted in the office, and you come up with a barnstorming first presentation. We've got 4 more presentations to come, but you know, this is a hard act to follow. Chris, great job. Thank you. Yeah, I'm with you in that, you know, the focus towards circular economics, and the economics as being a fundamental part of that. A few of the questions have been, you know, around, does this make sense? Will you make money? Well, there's only one reason I guess you're doing it, Chris, because it is a business opportunity. But let me jump to a couple of specific questions. So here's one from Doug Fowler, Chris. He says, if Tesla's new battery chemistries, iron, nickel, manganese, etc., become prevalent in the broader auto industry, how might that impact NeoMetals' business case, if at all?
Yeah, look, certainly we can see this, and the earlier slide where I had, you know, the lithium cobaltate on the left, all the way down through to 811 NCA, and look, I think if you have a look at the forecast for nickel and cobalt prices in the back half of this decade, and by 2030, you'll reach a point of indifference between nickel and cobalt. They will be multiples of what they are now, and so removing the cobalt and moving to more nickel really, you know, does not make any difference in the long term. Albeit in the short term, there is a difference, right? At the moment, cobalt sulfate is probably twice the price of nickel sulfate. And so, you know, there would be a short-term impact, but, you know, as the volumes grow, you know, we are confident that in the long term, it will have no negative effect.
Okay, thank you. And then Fernando Aguilar Lopez, similar question really. How flexible is your plant regarding battery chemistry? Does the feedstock need to be homogeneous? I mean,
well, look, with any processing plant, the less variability in the feed, the better it would work. And certainly what we would do is we would so we could have the shredding plant physically separate from the hydromet processing plant. So we would assay all the time the shredded material and the black mass. And so we would have stockpiles, not different to a mine, where you would have different stockpiles of ore, and you would blend them to achieve the least variability into the feed. With respect to the chemistries that we can stick in the front end, the only one we're not really keen on putting is lithium iron phosphate. So,
okay,
you know, we're trying to get not get much fluorine in.
Okay. Well, look, for now, Chris, and I'm going to recommend you get either some kind of, you know, coffee or something like that for a bit of time, because we've got some great presentations to come up, but we will go through a lot more questions at the end because they're certainly coming in. But just to remind everybody, yeah, please put your questions in the Q&A. We will do our very best to go through all of them at the end. We may aggregate a few together if they're similar. But this is as much about you being involved as it is listening to these wonderful speakers. But for now, yeah, that's Chris in Perth. We're now going to travel across the world, my friends, to Canada. So we're now going to listen to Ajay Kochher in Ontario, if I'm not mistaken. He's the CEO of Lifecycle. Is that correct? Are you in Ontario?
Yeah, Ontario based, but you know, North America, globally focused. Correct, Ron.
I've got to tell you, sort of trying to work out where everyone is these days is kind of bang easy because no one's other than at home. Very few.
Yes, and our wonderful backgrounds help to provide the company branding as well. Sorry,
yes. Yes. So Ajay, please take it away. The floor is yours, my friend.
Thank you very much. And thank you all for tuning in and for your time. As Roger said, my name is Ajay Kochher. I'm one of the co-founders and the CEO of Li-Cycle. We are a lithium-ion battery recycling company, as the name would suggest. And what I want to do in the next 15-ish minutes, and then leaving some time for Q&A, let's just take a step back. And I want to provide you with our view here on this space, what the macro need is for lithium-ion battery recycling from a high level on a global scale. And I'll spend a little bit on what we do and where Li-Cycle is at, and then we'll have some Q&A. Now, before I dive into this, and just to introduce our team in just a few minutes here on our story, look, our company, Li-Cycle, we are the largest commercial lithium-ion battery recycler in North America. We were founded 4 years ago by myself and Tim Johnston. Tim is to the left of me there on the slide. And we come from originally the lithium industry, as well as cobalt and nickel. And really our careers originally were focused very much on the mining and refining of material, and particularly the refining piece. So supplying these same critical materials into batteries, but from the primary space. And we used to engineer plants that do that at a very large scale, from early stages to building them through the whole life cycle. And so we left our careers doing that 4 years ago this year to start Li-Cycle on a conviction of two things. Number one, that there is this immense not solved problem as the last and missing supply chain step as part of the electrification revolution, and that is the sustainable recycling solution for end of life. But two, and more at the core of what Li-Cycle is doing and is solving in the long term, is also the supply of recycled, secure, critical materials from a secondary source. So we were doing, projects in the mining refining space for a very long time, and we would get asked, hey, Ajay and Tim, when are we going to start seeing more recycled lithium and more recycled nickel and cobalt coming back into batteries? And we didn't see the answer to that. And as I'll get to later, there is this issue with the existing approaches, the existing recycling supply chain that needs to be solved. So that's why we started Li-Cycle. Very privileged and feel very privileged that we've assembled a world-class team, board advisors that you see here. We're over 60 people today, growing to over 100 people by the end of the year. So I'm not going to dwell too long here on a couple of things you probably know, but the lithium-ion battery recycling industry is a new industry in that the source of our material is on its own path and continues to be commercialized, and how timely given Battery Day yesterday. Just as a reminder that our part of the industry needs to keep up with that evolutionary and revolutionary change that we see in the lithium-ion battery industry, which, as you see here, has gone from what we know and into the future won't stop, all the way to things like aviation and future state batteries, which will take time. But as recyclers, we need to be ready for that. And we need companies that are forward-looking and premised on first principles innovations to really make this happen. So one of the core areas that I really want to hit on here is critical material supply and demand. Now, you're tuning into these sessions, perhaps you've attended the other benchmark sessions or have in the past. These are actually benchmark charts. And what I have here are 3 charts for lithium, nickel, cobalt. And this is really the supply-demand balance. Now, I think a lot of folks here will be familiar with this. I don't want to belabor it. But the point is no matter, the change announcements in our world vis-a-vis yesterday, or just in general, what we're hearing and seeing on a day-to-day basis, the bottom line is that critical battery materials and battery grade are having a hell of a time getting supplied, and it's continuing to go through various cycles, and those cycles are not linear, and demand nonetheless continues to increase. I mean, the vertically integrated group yesterday aside, this is the way of our world that you just heard from Chris. And so I think everyone knows that. But there is often this distinction that needs to be made between material in the Earth's crust and battery grade materials that are suitable to be used in lithium batteries again. And those are not the same things, I think, as everyone on this phone or on this Zoom call will generally be aware of. So that's the case for lithium. Of course, today pricing is depressed, but at the macro level in the next 5-10 years, this is no different. This hasn't changed. Going to zero cobalt cathode chemistries, potential. I mean, this has been talked about for a while from other cathode makers as well, but you still have a lot of cathodes that have cobalt in them. And the demand continues to increase, albeit this might change in the future, but the same point holds, that you have this continued supply deficit relative to demand that is continuing to appear, and the same holds for nickel. Now, nickel is a different market, of course, but again, same theme. Just to be very clear, these charts, just so it's totally clear, this is basically demand minus supply, right? So, or supply rather minus demand. So if you have a deficit, this means that there's a deficit of supply relative to demand. This is primarily due to rising demand. This is also due to the inelasticity of these markets to react quickly in many cases. But just to be very clear, this is the balance. And hence you see that dipping below the negative line there. So I think that should be clear to everyone, and you probably are familiar with that in general. Another big question here is then, well, how many batteries are there to be recycled, and where will they come from? You know, we as pioneers, humbly I'd like to say, in this space and having to try and innovate and be at the vanguard, a couple of years ago, there really wasn't much out there to really quantify the amount of lithium batteries available for recycling. So we've taken it upon ourselves, and this is a model we continue to update. I'm glad to see, Chris, you're citing it as well. Essentially the total addressable market of batteries available for recycling, and that's what this is. And so this is segmented by region: North America, Europe, China, you can say rest of world on the top, inclusive of APAC ex-China. And this is in tonnage of batteries available for recycling per year. There are a lot of batteries coming. I think everyone knows this. I think part of the questioning and discussion around recycling is, well, there's a lag and this won't be happening for a long time. People often say that. But the reality is it takes time to set up these sets of infrastructure and the supply chain groups in the supply chain, and hence we need to be ready today. And so again, for clarity, in the next 10 years, our estimate is that there are over 15 million tons of lithium batteries that will be available for recycling. And this is, again, developed by us based on external sources of a variety, including Benchmark actually is one of the inputs at the root data source, if you will. And taking the same data and then segmenting that by then the various segments of lithium batteries available for recycling. This is segmented by manufacturing scrap. You have consumer electronics, EV batteries, and energy storage. So again, the point being that a lot of batteries coming, but also to emphasize the point that the market is changing from today into the future. Today you have manufacturing scrap, and consumer electronics is a very important source. Into the future, as EV batteries are at lag with their initial life, that will change, and you'll start to see more spent xEV. And let us not forget, this is not just passenger EV batteries. This is also bus batteries, micromobility, other segments. This is quite wide-ranging. So the message here is there will be no shortage of batteries to be recycled. And it has always been a question around timing. I think our view on that is Lifecycle, that timing has been misjudged when folks are talking about this being very far away. It is certainly here today. And back to the original macro point, there are a lot of critical materials in those batteries to be recovered. So this is a few of those materials: cobalt, nickel, manganese, lithium in those lithium batteries. Just taking a data point here. So looking at 2025, you see it called out that there's about 20,750 tons of lithium metal equivalent globally in lithium batteries available for recycling, which, by the way, takes into account the potential for reuse. That's in these numbers. So that is equivalent to over about 110,000 tons of lithium carbonate available from recycling by 2025. And if you subscribe to various demand estimates, which are completely wide ranging, I'm just going to choose a round number, 1 million tons of lithium carbonate demand by 2025, well, that becomes quite appreciable. That is circa 10% of the global demand for lithium carbonate. So again, what's the point? The point is that this is not going to completely replace mining in the near term. It is an absolute necessary additive and supplementary feed, but it is changing in our world that pre that time period, which is upcoming very imminently, this hasn't been the case. And a part of that has to do with technology, infrastructure, supply chain, and the ability to actually transform those batteries into those materials. So that is where now weaving into the life cycle side, where what we do comes in. I want to spend a few minutes here talking about who we are and what we do. So let me be super clear on a couple of things. As I mentioned to start, we are the largest and commercial lithium-ion battery recycling company today in North America. This is not a theoretical R&D piloting project. We've been doing this for numerous years now. It has taken time to innovate new technology, which I'm going to talk about in a moment, but scale it up. And I'm going to argue in this industry, there are a few things that will set companies apart. I think one of those things is most importantly doing this. I think that there are many models that might espouse, and there's different recycling technologies where maybe that's the desire, but licensing in this industry from a life cycle vantage point, I think will be tough, especially for replicability. And second, there is value to be realized in doing this. And that is the way that we will make progress in this industry around the world is by actually partaking and actually commercially operating. So we have done just that. We do espouse a spoken hub model. I'm glad that others have taken inspiration from that, but we'll take it as flattery. But I think to be very, very clear, there are many models that use this first and second stage processing as the basis. It's basically the concept of pre-processing and post-processing. In our case, again, the spoken hub, what is it? The spoke is a safe size reduction technology where we take in any lithium-ion battery, regardless of size, form factor, chemistry. By the way, we are not fussed if we need to take lithium iron phosphate batteries. We do today commercially, and we are actually happy to take them. And that's actually a sore spot of the industry, keeping in mind that that is about 20% sometimes of lithium-ion batteries available for recycling. So in our spoke, we safely size reduce that in an automated fashion, mechanically. And so what you have is batteries coming in and output as a product are three key materials: plastics, copper, aluminum, and what is known as industry as black mass. Black mass is the cathode anode material from within the lithium-ion battery. That is really where you have your lithium, your nickel, your cobalt, again, depending on the chemistry, but that is the key source of those critical materials. So that's the spoke in our context. The hub is then where we take in that black mass and we're processing that hydrometallurgically to produce battery grade end products. So things like lithium carbonate, cobalt sulfate, nickel sulfate, and other materials that are battery grade. So a couple of points then, what's different here and where are we today? As I mentioned, on the second point, we are commercial. We have an existing spoke in Kingston, Ontario, Canada. We today, as we speak, there's a small photo there, the left there, we're processing 5,000 tons per year of lithium-ion batteries every year through that facility, through commercial contracts. We work with the largest electronics OEM companies in the world on the automotive as well as the electronic side. Names that you'll know, we're contracted with them, we're commercial with them, we service their batteries through this model. And where life cycle is going is towards the hub. One other point, we are building a second spoke in Rochester, New York, in the Kodak Eastern Business Park. That'll be another 5,000 ton per year facility. So we are well into commercializing this model. It's happening today, we're commercial, as I mentioned. Now, what the industry needs, and I'm happy to expand on this in the Q&A, is actually more as well on the latter end. There's a lot of value in the pre-processing, but it is the value that is needed on the hub end, which has been a sore spot for the industry. And I can get to that in a few moments. So we're moving in that direction. The hub technology for us has been demonstrated, it's proven. We're not running a demonstration plant anymore. We're on a track now to scale it up to be commercial. Again, in the whole vein of doing it and being commercial in this market, this is the path that we're on. Last point is both these technologies are patented, 100% owned by Li-Cycle and developed by us. Just in the interest of time here, I'm going to move a little bit ahead here. Look, at the end of the day, our customers care about economics, recycling efficiency, recovery rate, safety, and environmental impact. There is an older part of this industry where pyrometallurgical high temperature processing has been the norm, and we are changing that. We do not use any high temperature processing. It's a critical part of the benefit that we derive. Another big part of this is also environmental benefit. So we have gotten independent life cycle analyses done on our process end to end. And this is, by the way, not just our direct processing, but it's also the full supply chain. So even transport, end to end, everything, a true life cycle analysis. And that results in a footprint that we have both directly and indirectly. And on the other side is a quantification of the footprint of mining and refining, all on a per ton of lithium-ion battery basis. So when you take the difference between those two, that's our net benefit. So per ton of lithium-ion batteries that we recycle, there's quantifications here for NOx, SOx, and water usage, we enable a benefit of at least 5 tons of CO2 for every ton of battery that we recycle, and all things considered. This is really, really important as this industry continues to evolve and as regulations continue to really hone in on GHG emissions and footprint. So we had an announcement today, and it was actually announced last week by Governor Cuomo's office in New York State. After a competitive site selection process and through our continued work and being commercial and explain why we're moving this direction, we have announced a large commercial hub in Rochester, New York, in the old Kodak Easton Business Park. And this will be a 60,000 ton per year facility. So 60,000 tons per year of battery equivalent input, which is, by the way, about 25,000 tons per year of black mass, and producing meaningful and large quantities of end products, so lithium, nickel, cobalt, and much more. This will be the first facility of its kind and scale in the world. We as Li-Cycle have been to facilities all over China, all over Europe, all other parts of the world. The reality is today that there is a large shortage of facilities that can actually process black mass at scale and at a fit for purpose basis. This is what we will be doing. And it will be also, importantly, a domestic critical material source. These materials in a US and North America context as well. So this facility will cost $175 million of CapEx. We've announced this. This comes to another one of my points on what will set groups apart in this space, but also as a challenge and an issue, but also an opportunity for companies of our nature, and that is capital raising. How you're going to fund the large infrastructure that is needed for this industry. We're just getting started. 60,000 tons per year is about 10% of the expected global market in a few years. And following thereafter, we really need larger plants. Even 60,000 tons in the future may not be large enough. So I cannot say too much, but we have an exciting announcement coming. I'm going to leave it at that in the coming short period, which is going to help answer the question also of how we are going to fund this site. And I'm going to leave it at that. So I see Roger, and just to wrap up here, I think just one last point is coming back to my original thesis. This is, again, the important secondary source to meet those critical material supply deficits relative to demand in the coming years. And this is our production of lithium, nickel, cobalt through this plan in the coming years via our global expansion. This is where we're going. At the core of it, Li-Cycle will be a sustainable battery materials company. That is what we're doing. We're very excited to be here and looking forward to the Q&A. So thank you very much.
Ajay, thank you. That was fantastic. So I mean, you're busy. You've got some big stuff going on there, and that's a big commercial investment in the States, and it's great to see a lot more people talking about countries, and let me try to not be partisan either to Europe or America, but basically anywhere that's not China. It's good to see a lot of that going on. But let me jump into a quick question. So this is from Mario Ruiz. He is saying, would a drastic change in the common form factors of batteries affect your manufacturing operations?
Good question. Short answer is nope. We today, the reality is I think anything, the largest form factor, talking out loud, that one might get is a Model 3 pack, and the 4 modules therein. There are 4 modules. They're the full length of the pack. A lot of folks might have seen the construction. That's the largest module on the market today that we've seen, and we can process it. However, I think an important point is you do have this changing movement also towards cell to pack, different pack infrastructure or pack design. And we're completely flexible to take that full gamut. But it's important because it is talking about challenges. For recyclers, we are the end point of that total set of degrees of freedom. And so it takes innovation to be able to make sure that you can take that full gamut. And we are set up to do that.
Yeah, yeah, and that's a good point. And it would be nice to see OEMs starting to scope into some of their design of packs, and modules, recycling in mind, just to make it easier and more flexible, and to add to that kind of commercial proposition. One final question then, Ajay, from Paul Renken. Will the businesses be based on being paid to take the batteries or purchasing them? That's an intriguing question from Paul.
Yeah, great question. Yeah, I think there's 2 parts of the answer. I think the historical industry has been reliant somewhat on being paid to make recycling work. And it partly has to do with legacy infrastructure, waste-oriented companies. It's not really being a very large market historically. So that's been the norm. However, there is a need as this industry matures that we move away from that. Now, lithium-ion batteries are a complex basket of various materials, but at the end of the day, there's a lot of valuable materials in them. So we as Li-Cycle have a very flexible commercial model. We can do a range of things, but I think that's very important for this industry moving forward. And from the automotive OEMs, there will be an expectation, and there already is, that in the long term, this won't be a large cost, and hence innovations needed to really transform the economic norm.
Yeah, we've got quite a few more questions on economics of it all, which I think will come into some of the other presentations. But for now, Ajay, that's fantastic. Thank you so much for your time. Thank you for going through that in absolute detail. So please don't go away. Hang around for concluding Q&A at the end. We'll be going through a fair bit of that. And then hopefully we can do this, get all our ducks in a row. So that would be good. We're going to fly all the way back now, obviously virtually, to Perth in Australia, and Andrew Spinks is going to join us. Andrew is MD of EcoGRAF, which is about high purity graphite for lithium-ion battery industry. So yeah, hopefully you're there. What are we now? 5 to midnight, is it, Andrew, for you?
Yes, good morning and afternoon to you, Roger. I should point out that the Tesla Battery Day started at 4:30 a.m. Here in Perth as well. So it's been a long day.
Have you been to sleep at all between that time and now then, Andrew?
I've had a few cups of coffee and I've just had another one. So hopefully all's well.
Excellent. Well, look, I'll say no more and shove off and leave you to it, my friend. So it's all yours, sir.
Oh, thank you, Roger, for the introduction. EcoGRAF, we're focused on providing obviously an anode material. We've spent 7 years, $35 million developing a vertically integrated graphite business, really positioned to support the global transition to clean energy and e-mobility. A quick read of the disclaimer. We've developed three business cases over those 7 years. I guess the really important aspect is they're standalone businesses and very much focused on markets outside of China. The key highlights, a quick overview of the key highlights of the mine is that it's development ready. We're pursuing a debt financing process with Germany's largest state-owned bank, KfW, through our partnerships with ThyssenKrupp and Sajits Corporation. We believe our Panko project is probably one of the best undeveloped projects. Kwinana development to produce a battery grade graphite for the anode market is the result of the last 4 years' work, and this is a scalable project based on a multi-jurisdiction location. We're starting off with our first facility in Kwinana. It's sort of centered around a chemical process that does not use hydrofluoric acid. It's a very friendly chemical process. And that really underpins our third development, which is the topic of today, is recycling, using our eco-friendly non-HF purification in the exciting new field of recycling and recovering the carbon anode material. All right, a quick overview of the company. We're obviously based here in Perth, Western Australia. We have piloting facilities in Germany that's done an enormous amount of product testing. We're listed on the ASX. We've got a secondary listing on the Frankfurt. Market cap is around 62 million at 17 cents at present. Our largest shareholder is Mitsubishi Financial Group at just over 12%, and board has a significant holding. The market is compelling, as we all know. I guess the battery market from an anode through the anode lens. Our business is to provide a clean, green, alternate supply to the battery manufacturers of graphite. I guess the really important aspect is all this material is coming out of China, and there is no other supply. The other interesting aspect is the anode composition is quite simple. It's a combination of both natural spherical graphite and synthetic, with a small percentage of around 3% of silicon. And as we've seen today or yesterday, the announcement by Tesla to increase the silicon content is quite exciting. One of the issues with silicon is that it expands 300%. So there is a safety factor, and it looks like Tesla have developed some sort of cushion or binder that sits around the silicon, and it looks like they've got aspirations of increasing the silicon to 5 to maybe 15%. In any event, whatever the silicon content is, there's going to be a requirement of a huge demand for graphite in the future. The investment in Europe, as we see, is enormous, and I guess what's really surprising us, because we've been developing the graphite business over the last 7 years, is the massive supply risk all this investment has. There is currently no other supply for battery natural spherical graphite. It all comes from China, so we see that as a massive supply, and where our business fits very nicely as an alternate supply. The good news is the EU is now sort of recognizing it and starting to draw up where this raw material is going to come from. And also over the last week, we've seen increased interest from the EU on recycling. An overview of our graphite business, our downstream business. We've done an enormous amount of work. It's centered around the purification process. We've completed engineering studies, optimizations, enormous 3 years of product qualification. We've signed our first offtake with ThyssenKrupp, and we're progressing a financing arrangement with the Australian government. The capital cost is set out below its stage, matched to market, and the returns are very attractive. The reasoning for putting the location in facility selecting Kwinana was really twofold. One was the very strong government support, but secondly, the strong European customer support from Europe and the US looking for an alternate supply. What I'd like to do now is just share a video. It's a 2-minute overview that will just give you an overview of our facility in Kwinana, and then we'll talk about the talk about the recycling business.
EcoGRAF has invested substantially over the past few years to establish a unique and environmentally superior graphite processing technology. The proposed EcoGRAF facility will initially commence with a production rate of 5,000 tonnes per annum, followed by an expansion to a capacity of 20,000 tonnes per annum. The state-of-the-art new process plant eliminates the use of hydrofluoric acid, and instead the EcoGRAF processes produces graphite in 2 stages. Firstly, the mechanical shaping of the graphite, and then multi-stage chemical purification. The purified graphite is then dried and bagged prior to transport. EcoGRAF high-purity graphite will be globally exported to lithium-ion battery markets. The facility is expected to employ more than 250 construction employees and 60 direct employees during ongoing production. It is expected to generate significant royalties and taxes over its first 20 years of operation. Demand for high-purity battery graphite is forecast to increase 700% by 2025, with growth expected to shift into Europe and US markets. The EcoGRAF Kwinana manufacturing facility will be well positioned to meet this growing demand and be part of the massive global investment to transition to ethical renewable energy storage.
Video's
So
gone
that
off,
was
Andrew.
yeah. Sorry. So that's that was just the sorry. Let me just share the stop. Sorry. Share. Yeah, sorry about that. So we're back. We're very close to finalising the lease on that site. So we're close to finalising the lease with the state government. The next slide provides an overview of what we see entitled with the slide is closing the carbon loop. The challenge that we see with recovering the carbon is at the moment the carbon material is not currently recovered is landfilled. So there is going to be efforts required. We see two product streams: production scrap and black mass is the two product streams that we're looking to recover. At the moment, recycling efforts are focused on the cathode, as we've heard, and that is going into base metals. The opportunity that we see and from recovering the material is a reduction in the battery unit cost from recycling the anode material, and obviously contributing to a lowering in the carbon footprint. We see the solution is very much circular, and collaboration is critical. We take the black mass, the carbon material, after the hydrometallurgical process, and then look at recovering the carbon. So we see leadership required from the electrical vehicle manufacturers and lithium-ion battery markers, with collaboration with the hydrometallurgical processes, because we take that material. The results we've received to date are very positive, and we've been able to recover high purity carbon anode material and demonstrates the powerful process of our EcoGRAF purification. And as a result of those results, we've updated our patent to include recycling within that patent application that we have. The purification process is a multi-step process. It's cost effective, and to recover the anode material. I guess the other key aspects of the process is that it's non-toxic. There's no toxic gas or residues. It can be located in any industrial park, and it's a very all the chemicals that we use are available in all those parks. As I said, the results we've received are exciting, and they're for both production scrap and black mass. We've achieved up to 100% on the production scrap, and not up to 99.6% on the carbon, black mass carbon. And we believe with further work on the purification, we can get that grade up higher. The good news is through that process, we've been able to retain the particle shape. And this is a microscopic image of the recovered carbon anode material. And it's the oval shapes, as we can see, is the natural spherical graphite. And what we're also seeing is the plate or platy synthetic material. And I guess the importance of retaining the shape is critical, because one of the biggest contributions to putting this material back into reusing into the battery is the particle shape. It's a major specification requirement from the anode. So it's quite exciting that we're seeing the original material maintaining its shape. Our strategy to recover and reuse the carbon is on two efforts, and this is an overview of our strategy. Firstly, we've got the lithium ion cell manufacturing down the left-hand side. We're looking at the production scrap coming through the hydrometallurgical processes, and also end-of-life batteries coming in. So this material, black mass, after the cathode metals are taken out, we pick that up and purify. And we're working on a couple of markets to put this material back into, in the natural graphite market and the synthetic, because this is a composite material of both natural and synthetic. What is exciting for us is taking this carbon anode scrap and potentially taking that off the waste shop floor and recycling and putting that straight back into the market. And that's an in-process closed loop opportunity, and that has significant financial benefits. The production scrap market is a large market. This is a table, a graph presented based on information from Panasonic and Tesla. Production losses during cell production is significant. Yield losses are largely due to testing, battery testing, but potentially in the early production, it's up to 30%. And the target for the battery manufacturers is 5 to 10%. And even at the lower estimate of 5, there's a lot of volume of production scrap. And that's significant on the emissions front. And this is a graph provided by No Canary and based on Volkswagen. It's a graph showing the footprint of the EV production, and the battery represents over 40% of the carbon emissions footprint. So that is quite significant in terms of the production scrap, the impact of recycling this material, and then the longer term objective of introducing and reusing the black mass. So recycling of the carbon anode material has an important role to reduce emissions. So we see closing the carbon loop as a critical component for our business. We see a tailored and customized solution for this material. for those two key benefits, which is really significant. And I guess the unique benefit we've got that we bring as part of our vertically integrated business is the blending using this high purity graphite that comes with a credit. You know, it's slightly above the specification. The specification for battery spherical graphite is 99.95. So it comes with the credit, and we see blending that with this recovered anode strengthens the ability to blend that recovered anode material back into the battery. So coming back where we began on the mine, just a quick overview. There's an enormous body of work available on our website. We've done a significant work program on this. We've completed a bankable feasibility study. We've had an independent engineer through KfW that's supporting the debt financing. We see that one of the key benefits through that process is we've had to meet equator principles. It cost us about an additional $12 million through the due diligence process to meet the IFC performance standards of World Bank, which is really what the car manufacturers are looking for: a clean, green, raw material, responsibly produced. Panko has all the technical capability, technical aspects to make this a very commercial, profitable, long life mine. We're beginning with 60,000 tonnes and we'll scale up. And our partners include ThyssenKrupp and Sajits. And the capital estimate is modest, with 60,000 tonnes at 90 million, but again, very attractive returns for the company. So in summary, we've got a significant value proposition. Both the upstream and downstream are development ready, and we've now opening up the recycling using our EcoGRAF purification process. And I must say, this is just the beginning. This is very much scaled to demand today, not some unrealistic projection. So the future looks extremely bright for us. So thank you very much for your time, and I look forward to any questions.
Andrew, thank you very much, and thank you for talking to us from the future, because of course it's already Thursday there for you, isn't it? Or is it Wednesday? Honestly, the days just
I believe it's Thursday.
Yeah, that's right. Yes, it's Thursday. Yes, it's all coming back to me now. Thank you so much for that. There's so much going on, that I think is predicated on lots of forecasts and projections. So let's hope a few of them come in. But let's jump to a few specific questions. Here's a really good one from Tyson Wilmot. I'm really interested to know this, so I hope this is a really good test for you. How do you separate the synthetic graphite from the natural graphite and silicon?
Look, we're of the view that at the moment we're not trying to achieve any separation, so we're calling it a carbon anode material. I think that we don't think it is possible at this stage to separate it. May be able to in the future, because there is a particle size differentiation, but what we're focused on is reintroducing the carbon anode material as a composite back in.
Okay.
Into the marketplace.
Perhaps Tyson's asking the question as a tease because he knows how to do it. So if he does, he should get in touch with us, I guess. So this is from Chris White. Given the upcoming growth in demand for lithium-ion battery materials, do you think second life batteries would do more harm than good, since they delay the recycling stock feed by several more years? That is a good question from Chris. I was thinking that as well, because, if we look at use, reuse and recycle, the reuse bit's sort of in your way a little bit, isn't it? So yeah, what do you think of Chris's question?
Oh, look, I think the demand forecast for transition to clean energy, energy storage, e-mobility, we're going to have to recycle. So, reusing batteries is and recycling is a must, and probably consistent with what Chris was presenting at the beginning.
Okay. Look, we've got lots more questions, but as I said, I'm conscious that it's now Thursday morning for you. So I'm definitely going to recommend some more of that coffee you mentioned earlier, and say, you know, for the moment, Andrew, thank you very, very much for going through that with us. Don't go away.
Thanks.
Please don't go to
Thanks,
sleep.
Roger. I'm
Yeah.
going for a cup of tea
Good man.
or a glass of red.
Perfect. Yeah, we'll have both. Treat yourself. So we're going to jump back over now to the United States. Well, we're going to go to America for the first time. We're going to go to San Francisco, where, of course, quite a few of us probably were yesterday, maybe not literally, by way of Tesla's Battery Day. So I'm going to invite Ryan to the stage. Ryan is the CTO from the American Battery Technology Company. And Ryan, I must ask you this question first off. Were you in a Tesla in the car park tooting your horn to Drew Baglino and Elon Musk yesterday?
No, I wasn't there in attendance yesterday. I'm actually based out of our development laboratory in Cambridge, Mass at the moment. So other side.
Oh, okay, you're on the other side of the country. Yeah, you'd have had a long drive if you were there last night, so that's fine. So Ryan, look, well, welcome to the stage. You're a penultimate speaker. We'll do a few questions after your session, and then we'll go through a bunch of them at the end. We may go over by 5 or 10 minutes, but we always like to try and get as many questions answered as we can. So I see your presentation up there. I will go away and leave you to it, young man.
Great, thank you. So like Roger said, my name is Ryan Melsert, the CTO of American Battery Technology Company. So we are a publicly traded company. We have our forward-looking statements here. When we take a look at who ABTC is overall, our real mission is to increase the amount of domestic US critical and strategic battery materials that are produced domestically, and to really help move this whole manufacturing supply chain from the current linear fashion into a closed loop supply chain operation. So we have 3 different units for how we do this. We have our primary resource exploration development group. We own large amounts of mining claims in Central Nevada, where we have been working to extract and sample primary lithium from different brine and claystone samples. We've also been developing our own first-of-kind extraction techniques for novel ways of leaching lithium out of those resources and new ways of then upgrading that leach liquor up to high purity materials and specifically to high energy density battery grade hydroxide specifications. But mostly we're here today to talk about our lithium-ion battery recycling system. So what we put together is an automated integrated system for the universal recycling of batteries. So we're able to feed in all different types of form factors, all the way from large modules down to medium-sized cells, prismatics, pouches, cylindricals, and even down to slurries and powders and different types of manufacturing waste. And what we've seen in the industry is that while there are many companies who can do that initial part of the process, taking those battery metals, extracting them from these feedstocks and upgraded them all the way to specifications that can meet what battery cathode manufacturers are requiring is critical to making these types of lithium-ion recycling systems economically viable. So at this point, we're moving forward with the construction of our first battery recycling facility in Fernley, Nevada. And we have our development facilities based out of Greentown Labs in Somerville, Massachusetts. When we look at the broader industry, what we're really seeing is that up until now, it really has been individual companies working throughout this manufacturing supply chain. So vehicle OEMs purchasing cells from many companies, cell manufacturers purchasing refined material from many companies, and then buying battery metals, mostly from commodity markets and a few specialty chemicals. But as this industry ramps up so quickly, what we're starting to see is the blurring of the lines between these 4 groups of companies and many different types of alliances or consortiums forming, where companies in each of these groups are starting to invest in each other and really move to an integrated network where one consortium can have ownership of these battery metals throughout its entire life cycle. And when recycling is included, this can be an indefinite life cycle. Really, once you purchase these critical materials the first time, if you have a group, a company in each of these groups working together, you can keep making that work in a closed loop. So at American Battery Metals, we see the combination of our battery recycling technology in combination with our primary extractions and the introduction of virgin resources, our brines and clays and ores, that injection of material is really going to be required for the next few decades, really until the occupied mass of batteries on the market is at steady state. We will always need to be adding new materials into the system. And what's often overlooked is the overlap in processing technologies between these virgin and recycled applications. So while the initial pretreatment of virgin or recycled materials is very different, once you get to the middle and back end processes, we're able to take opportunity of many economies of scale. So many of our purification systems, our conversion processes, our hydroxide crystallization systems, and even our quality control and balance of plant are really able to take advantage of combining the processing of both our virgin and our recycled material. So why we're here in general, we know that there are huge amounts of growth in the battery cell manufacturing and end-use product manufacturing globally and specifically within the US. But the introduction of battery metals and the refining capacity of them is being dramatically neglected. So as Benchmark says very well, the growth of battery cell manufacturing globally will grow more than tenfold over the next 10 years. The end-use products, the vehicles, the stationary storage, consumer electronics, their growth is really being limited by that cell manufacturing. But even more upstream of that, the cell manufacturing is really being limited by the production of these battery-grade metals globally. And unfortunately, when you look within the US specifically, what we're seeing is that each of the 4 critical and strategic battery metals that are needed to make these types of high energy density cathode batteries, less than 1% of each of them are currently being sourced within the US. And because of that, there's actually very little manufacturing of high energy density cathodes in the US as well. Again, far less than 1% of global capacity. So while there may not be as developed reserves of each of these elements domestically, what we're seeing is that battery recycling can play a large role in reintroducing these elements back into the domestic US market to make up for that lack of capacity in the primary side. And in general, we say recycling can make such a big difference. Why isn't it more prevalent? And when we're speaking with large industrial players, speaking with consumers, a lot of the hesitance to reintroduce the material back into the market is that most facilities still charge essentially a tipping fee. They require to be paid to pick up and transport and take material away. This really creates a disincentive for material to go back into the market. And many industrial customers end up hoarding their end-of-life materials. Many people on this call probably have old cell phones or laptops in their desk drawers or closets that you may want to recycle, but as of today, you would have to pay a fee to have that actually processed. So we see that holding back the industry. And when we say, why really is there a tipping fee? It's mostly because of the design of current processes. And a lot of the government interactions, again, are really more based on the carrot and stick approach. Most governments are trying to punish manufacturers and consumers for not recycling material, trying to force them into doing something that costs them money. Whereas we really see the carrot as a much more effective tool here, where if somebody can really develop an integrated recycling system that operates with sufficient margin, that the companies can afford to pay for material to come from those hoarding locations back into the market, that will pull material back into this reintroduction much more easily than punishing people who don't do it. So many of the recycling facilities that operate today really aren't able to function economically if they didn't have their tipping fee. And that really is because a lot of the legacy companies that are trying to do this are operating facilities that really weren't designed to recycle batteries in the first place. Many of them were meant to recycle scrap metals and stainless steels, where they're physically able to fit batteries into their system, but they really weren't designed for it. Many of these use bulk pretreatment approaches, the bulk calcination, the high temperature operations, the bulk dissolutions of the initial material. And while those may make for simpler operations, once you get downstream, it makes it much more difficult to then extract each of the elements of value in a high efficiency manner. Many other systems, operators are hesitant to handle charge batteries. They require expensive bulk discharging of cells and modules and packs, which can be difficult at end of life when they may be damaged. And after discharging, they require expensive manual disassembly, physically separating large modules and cells from packs. And for small form factor cells, that makes it especially expensive. A lot of other operations operate their water and chemical reagent systems in an open loop. So while we're trying to move these battery metals into a closed loop operation, the chemical reagents and water are going the other direction. These end up driving very large percentages of the operating costs of these facilities. And operating them in open loop, always needing to be buying new consumables and exposing of the waste products dramatically adds to the operating costs and decreases margin that could otherwise be applied for purchasing feedstock to bring it back into the market. Other companies were able to operate but really don't have high separation or recovery efficiencies. That again leads to lower revenue. And one of the biggest ones we see is that extracting these battery metals, but only selling them back to the industrial market or the Chinese grade market, really leaves money on the table. That if you're not able to sell them back into the high energy density cathode manufacturers, you're not giving your maximum revenue, and you're also not really enabling a closed loop system. So myself and many members from the American Battery Technology team, our background really is in the design and construction and commissioning of battery construction facilities for battery manufacturing. So we joined the Tesla Gigafactory team back in early 2015, back when the factory was still a patch of dirt. They were just a handful of us in construction trailers out in the middle of the Nevada desert. And we were a part of every part of that operation for designing the physical facility, the cell manufacturing layout, the utility systems, the environmental controls per room, and then especially seeing different types of waste material that were made at every stage of that cell manufacturing operation. There were defects, there were yield losses at every single node in between the unit operations. And a big part of our early work was understanding at a fundamental level what the failure mechanism was that resulted in that specific material not meeting specifications for that stage of manufacturing. So inadvertently, we found many ways to make battery cells fail, essentially, by having incomplete manufacturing in the high-speed operations that were going on there. We saw large amounts of waste piling up on site, but it was really that understanding of why material fails, why each step of operation can have a failure, how you can have separation of components. That was very key to understanding there. In our latter 2 years within Tesla, we ended up founding a battery cell material processing group within the R&D division. And there we were really working with unconventional resources throughout the world, different types of lithium and cobalt and nickel resources, in trying to develop first-of-kind systems for how to extract individual elements from those resources, first-of-kind systems for purifying them, how to convert them into precursors, and then how to actually make our own cathode hydroxides and active cathode material from those unconventional resources. And again, while the initial leaching and extraction systems were very dependent on those primary feedstocks, once we got into the purification and back-end conversion operations, they tended to streamline. So we very naturally saw that we were developing first-of-kind systems for the extraction of battery metals from unconventional resources, and we had large amounts of unconventional waste piling up at Gigafactory. So we naturally worked on different methods of extracting individual elements from all different types of battery waste from manufacturing operations. really specific to the Tesla design. While we were productive in doing that, we presented to executives many times. It was approved to build small pilot facilities many times, and never really rose above the attention or the capital requirements to move forward within the company. I mean, as we saw yesterday, it seems that they're still working to focus on the manufacturing side and really waiting, they mentioned, about 10 years to really have dedication to bringing an integrated recycling facility online. So after our team left there and went and joined American Battery Metals, we came back to the drawing board and said, we really don't want to just focus on one company's type of waste. We want to look at the entire industry. So we looked at all different types of form factors, all different types of chemistries, and we came up with what we're calling a universal battery recycling system, where we can process much larger prismatic-based cells, different types of module-level form factors, and different types of chemistries in an integrated fashion to enable this universal battery recycling system. So when we went back to the beginning, we looked and said, the entire manufacturing supply chain from the beginning really breaks up into those 4 different groups we showed at the beginning, where you have raw ores and brines, extracting individual elements up to commodity feedstocks, purifying them to battery grade specifications, going through chemical refining operations, through cell manufacturing, and up to end use OEMs. The materials are then going into end use products, electric vehicles, stationary grid storage systems, power electronics, consumer electronics. And then at the end, you have this end of life material, a very different set of form factors and chemistries. And you also have these brute force methods that are currently in place for how to process those that are not able to generate sufficient margin without charging tipping fees for the feedstock. So back from our days of understanding physically how to manufacture cells in very high-speed operations, the defect mechanisms that can happen in those operations, and then also how to extract, purify, and upgrade individual battery metal elements from unconventional resources, we developed what we called last year a battery demanufacturing system, where we have these high-speed operations for reverse manufacturing everything we did on the manufacturing side of the battery. And by doing this in a structured and strategic fashion, we're also able to not just mix manufacturing waste at the inlet of the facility, but we actually feed it in the corresponding portion of the demanufacturing train. So different powders and slurries that are made at the early portion of manufacturing, we feed into the back end of our process where we have the material back down into slurries and powders. The same with cell level waste into our cell deconstruction system, module to module, and then at the beginning is where we take the larger packs and module systems. And at the same time, we're able to generate products of value at each one of these nodes. So we're extracting module level, aluminum and plastic and power electronics at the beginning. Once we're breaking down the cells, we're extracting the casing materials, the foils, the low density materials. And then once we go back into our slurry system, we're able to extract the individual battery elements. And those 4 critical and strategic minerals shown at the bottom there, again, to stress, it is not trivial to extract those elements and bring them beyond industrial grade and actually meet the specifications that high energy density cathode manufacturers require. So we're excited to have developed this system, to have proved it out at moderate scale. And the key to lowering the costs really are the specific throughput of the system. So from the time material enters our system until it hits the back end and there's product out the back, takes about 3 hours for the entire residence of the system. So that really increases our throughput per capex of the plant, reduces the total facility cost, and reduces the amount of labor and human interaction we have with the facility. And then on the back end part, as we mentioned, turning the water and chemical reagent system from open loop processes to closed loop has made a dramatic difference in the operating margin of the plant. And then extracting those 4 battery grade metals as meeting battery grade specifications actually sold back to cathode manufacturers instead of just the industrial market, has resulted in our much higher margins. So we're excited that last year we were able to work with really the only high energy density cathode maker who has capacity in the US, which was, is BASF, who has facilities in Michigan and Ohio, actually making high energy density battery cathode material. They put out a competition the start of last year saying any company in the world who has a proven process for recycling lithium-ion batteries, apply to this competition. Whoever wins will take you through a 6-month accelerator process hosted at Greentown Labs, so the largest clean technology incubator in North America. And the winners would receive seed funding, access to facilities, and really contacts and relationships with every portion of their organization. So they say about 250 companies applied to this last year, and we're very excited that we were chosen as the sole winner of the battery recycling portion of this competition. And now moving forward, building relationship with the only high energy density cathode manufacturer in North America really has allowed us to ramp up our commercialization and blur the lines between those silos of really what is a metal manufacturer, what is a refiner, what is a cell manufacturer, and move to that true closed loop operation. At a very top level, our system really consists of separations up front of the system and that highly automated operation again. We are able to take the water generated from our rinsing operations up front through an in-house developed water treatment system. We're able to treat that water all the way past the quality of our own well water on site and actually turn that back around into a closed fashion. And then again, just at a very top level, our back-end process really does include a hydro-based process, but we're able to synthesize our own acid, our own caustic, and our own oxidizing agents on site that really allow us to avoid the large operating costs of constantly buying those from the open market and constantly disposing their waste products back into the environment. So just at the end here, our schedule as of now is we kicked off this project last fall. We finished the design of our initial pilot facility at that Fernley site, and we're moving forward with the construction of our operations right now. We'll be adding our initial pilot operations early next year, and then adding further value-add operations at the end of next year. And this initial site we really see as a pilot plant, not just because of the throughput, but because of the flexibility that we're building into the facility itself. As we see form factors and structures of cells change, small changes to chemistries, large changes to electrochemistries going forward, we will keep reusing this pilot facility every 1 to 2 years to revalidate a new technology of recycling different types of batteries as they come to commercialization. Early 2023, we'll be building our first commercial facility, about 10-fold the throughput of our pilot plant. And those commercial plants will keep operating really at even higher operating margin to process the majority of the systems. But that pilot plant will keep essentially as our skunk works, our development facility, to keep experimenting and keep developing for new technologies going forward, which will enable us to future-proof our business operations going forward.
I think that's going to be a pretty critical aspect of much of this journey, isn't it? We see and heard the innovation yesterday with people I'm sure you're quite familiar. Do you know Drew Baglino yourself?
I do. It's a relatively small team in the company, yes.
Yeah, I guessed it would be. Yes, I'm sure you found that pretty fascinating. Look, Ryan, thank you so much. Sorry, sort of nudging you along a little bit there. We are going to go past the hour for anyone wondering, because Benoit is our final speaker, and we'll hand over to him shortly. I'm going to give you one question, Ryan. This is from Alan Burns. He says, a large number of secondhand cars are exported from Europe and North America to developing countries where some years later they are scrapped. He's absolutely right, of course. He says this is expected to happen for EVs. Maybe he's right. We're going to see. How will that affect the availability in North America? Again, it's a bit similar to the question we had earlier on about reuse coming in the way of recycling. It's a similar sort of flavor of that. What do you think? Are we going to see lots of EVs shipped out to, you know, as cheap vehicles to countries that aren't so economically strong?
I think that's very likely, yes. I mean, that's how the combustion engine vehicle industry works already. I think one point to add to that is how quickly battery technology is increasing. A lot of the big limitations people feel now are not just the range of vehicles, but the charge time, as there are not just incremental improvements in battery technology, but also step changes. It's important to notice that a lot of the battery packs are built into the structure of vehicles that can very easily be removed.
Yeah.
So we also see people in the developed world who, even though their battery pack isn't anywhere near aged, if there's a battery coming out that has, you know, a 5-minute charge time for a 300 or 400-mile range, they may choose to remove their battery early, just to upgrade to a new battery pack to increase the functionality of their car. That may pull things forward, but yes, that older generation pack may then go to developing economies to help them electrify as well.
Yes, yes.
Impact on the availability of material.
Yeah, I think in all of this, we've got to be careful that we consider or try to consider the unintended consequences of some of what we're doing, of course. So, but anyway, let's pick up some of that at the wrap-up session at the end. But, you know, for now, Ryan, thank you. You've been on an amazing journey for 10 years. You know, those 3 or 4 years at Tesla you had clearly have stood you in good stead with what you're talking about now. So that was fascinating. Thank you very much. And I'm going to invite Benoit to the stage now. Benoit Couture is president and CEO of the Lithion recycling company. I'm just reading my notes here. It recovers 95% of lithium-ion battery components and generates high purity materials. So that sounds pretty impressive, Benoit. That's a big old claim there. We're really interested to hear just how you're doing that then. So hopefully you can hear me. I think we've got your presentation loaded up if there's any connection problem. But are you there, Benoit?
Realizing that I don't have the right video, so you won't see my face, but can you hear?
I can hear you. It's a bit muffled, but I can't actually see your presentation. I don't know whether Will or Ben has got it there that we can load it up. All I'm seeing is a little bit of the bottom of your screen at the moment. The audio isn't that good, Benoit, to be honest with you. I don't know. Can we get Benoit's presentation up, Will, from your end? He's going to have a look at that.
Just pulling it up now.
Okay, right. That's good. Will's putting up the presentation, Benoit. So he's sharing that. We've got your presentation up in front of us, the sustainable recycling solution. So if you can speak as closely as possible to your microphone, let's see how that goes. If it's not working, do forgive me if I come in and interrupt, but obviously I don't want you to be doing something and people can't hear it. So please forgive me if I do that, Benoit, but let's give it a go.
How's the sound right now? Is it better?
Still a bit blurry, to be honest with you, but let's see how we go. Give it a go, Benoit. Let's try.
Instruct when it's time to change the page. So I'm sorry for everybody. I'm experiencing difficulties with the system, and I'm hooked to a very strong internet pipe. But anyway, so thanks for being here, listening to the 5th guy in a row talking about lithium-ion battery recycling. I guess it shows that this is a very interesting and very important subject. So you can change the page. So I'm Benoit Couture, president and founder of Lithion Recycling. At Lithion Recycling, we developed a technology being able to recycle 95% of lithium-ion battery components, and we are producing battery-grade material that are looping back into a supply chain of new, real green. Our technology in 2017, we developed it with Seneca. Seneca is the sister company of lithium. Engineering firm specialized in process development and building process commercial plants. So our day-to-day business at Seneca for the last 24 years is to work with our clients and get their technology out of the lab and develop their process, build the first commercial plant, and put it to work. Decided to do it for ourselves. We looked at the recycling market, and I decided not to explain the recycling market and the needs to recycle, because I was very confident all the sport guys before me would have shown a very broad overview of the recycling market. So I decided today to explain to you differently.
Benoit, it's Roger. I'm not sure this is going to work. I've got to be honest with you. What's happening is it's clipping off the first part of your audio. So we're kind of just getting the tail end of your sentences, which is a real shame, because I can see from what's up on the screen, it's going to look like a really wonderful presentation to finish off on. But I honestly, I'm not convinced it's gonna work for everybody watching at the moment. Can we try and I don't know, Will, whether you can put up the full screen on there or not? But I honestly, Benoit, I don't think we're gonna do your presentation justice if we just try to do it, you know, and just not worry about it. I don't think the audio is going to improve. Give it one more go, but other than that, I think we'll have to do it another time, Benoit. No, it isn't going to work, I'm afraid. Look, can I invite everybody back, and we'll go through the Q&A session. Big apologies to Benoit for that. We did try it, first of all, folks, but what can often happen in these things is over a period of time, or in your facility with lots of people using your Wi-Fi, I guess everybody knows this stuff, it just drops the signal or just knocks you out completely. So these things happen. I'm glad to see Andrew there. He hasn't nodded off. You've done well there. How many coffees have you had, Andrew?
Just another one for the day, Roger. Very Sprite.
Another one. Another jug for the day. Okay, what we're going to do, we're going to record it separately and send it out to the attendees. So if you can hear that, Benoit, yours is actually going to be recorded like a special edition. So we'll do that and send it out. Right, thank you for joining us again. I'm not sure if everyone's there. So is Chris there? Are you there, Chris, or have you?
Yeah, I certainly am. Can you hear me?
I'm pretty impressed with you Aussie guys. You know, there you are at kind of 10 to 1 in the morning and you're still going strong. Very impressive. Right, let's ask a general question to everybody. Anyone who wants to answer this, please just jump in. Are the projections and forecasts that we're hearing for the adoption of EVs filling you with confidence or not? You've got such a range of forecasts from people like, well, whether it's Benchmark, for example, or Bloomberg New Energy, right the way through to some of the oil companies who, of course, project low numbers of uptake. I wonder why. Are you confident that we are on the cusp of a real tipping point for the adoption of electric vehicles? Perhaps Andrew, because you've been waiting up longest, you'd like to have a crack at that one.
Oh, look, absolutely. I think the projections vary in uptake, but you've just got to look at the sheer investment that's going on. The governments that are enforcing new regulations into EV, green energy, you know, you got your head in your sand if you don't think it's going to impact raw materials. I don't think anybody realised how much raw materials is going to be required. And in fact, why we're here today is because recycling softens the blow for the actual sourcing fresh raw materials. Recycling will play a critical role.
Yeah, and all of you have shown different, you know, propositions from different parts of the world. I'm wondering about trying to localize more of this, to put it, I think Chris was first up and showing a lot of where his proposition was right in the heart of a lot of the European manufacturing. How important is that? Because I guess transport, you know, moving stuff backwards and forwards must be a big chunk of the cost, and therefore the viability must be a quarter or a third at least, I guess. Chris, do you want to comment on that? Because I think that was your slide first of all. Is it fundamental to put some of these recycling facilities adjacent to the manufacturers, even though, of course, the manufacturers put them out to the market, the vehicles aren't necessarily there in situ still? What's your thoughts?
Yeah, sure. Look, I think, you know, the perfect configuration would be to put the smaller plant next to a cell making or a cathode making plant to shorten the supply lines. Ultimately, we can shred the material and truck it around because, you know, within Europe initially, because it is a high value feedstock. But I think if you have a look at Europe, certainly if you know, China's the biggest production hub for lithium ion batteries, then you got Asia, ex-China, Europe, North America, and you have very little domestic production of these materials. I mean, there's cathode makers in Europe, but the actual battery ingredients, there's not. So, you know, I think absolutely once it lands in there, you've got to set up a fortress and not let it out.
Yeah, yeah. I mean, there's a question here from Andrew Gorsden. He says, interesting that when carbon emissions are quoted, they fail to take account of the carbon cost of transportation of materials to and from recycling plants. Total life cycle assessment is critical when considering carbon reduction. I've talked to a few people about this, you know, over recent years, in truth. We can't just go on the journey of jumping out of internal combustion engines into electric vehicles without taking full account of, you know, the real net value of doing that, you know, and whether it's from use, reuse, recycle, or whatever. So yeah, I mean, this is definitely an arena. Ryan, I've got to ask you this question because it was definitely on my mind. It's come from James Zhu. Are you going to recycle batteries from Tesla? You know that JB is doing stuff. Benoit, sorry, can you mute your microphone, Benoit? It's now working, ironically. Yeah, Ryan, we know that JB has got redwood materials, which is interesting. So kind of with that in mind as well, what about James's question? Are you going to recycle from Tesla?
We've intentionally designed our process to be able to take in batteries of specific different types of form factor and chemistry. So the easy answer is our process is able to, but at this time we're not going to disclose any supply agreements, but we've intentionally designed this process to be able to handle specific types of cylindrical cells and modules, as well as the module types from other OEMs.
Yeah, I mean, some of your narrative struck me as being, you know, and it's just a compliment, by the way, quite sort of Tesla centric in that you are anticipating changes in form factor and all those other things, and you're absolutely bedding that into your process. So yeah, I kind of thought you might say that. Here's a question for Ajay from Max Goldberg. This could be interesting. It might be looking for some business. Is Li-Cycle looking for partners or franchises to open plants in other countries that are more secure for North America and Europe than Latin America and Africa? Yeah. So are you looking for partners, AJ?
Yeah, great question. So I think short answer is yes. You know, our business model here is twofold. So we've, you know, started by doing this. I mentioned the 2 spokes, the hub that we're building, and I'm going to make a second comment on black mass. But, you know, first and short answer is yes, we're looking at regional joint ventures, ex-North America, Europe, China, APAC, ex-China, other parts of the world, South America. So this is how we see a mode of deploying. We don't espouse a licensing model. It's not what we do. We want to be partners. There's a lot of know-how in how you do this end to end. We talked a lot about technology, but there's even things that might sound mundane, like storage, safety around that, transport. You know, this all takes know-how and actual ability. So yeah, so short answer is yes, we're looking for JV partners.
Okay.
Second comment I just want to make very briefly. Oh, sorry, Roger.
Go on. No, go on.
Just briefly is, you know, one thing I want to distinguish, and it relates to partnership, and it's not often talked about in our industry, and I think we need to start doing that more, is we have to always remember that there's kind of pre-processing and there's post-processing. The recycling that's been happening in our world today is primarily pre-processing, aka batteries to black mass. So battery separation through to cathode anode. There's a variety of ways to do that. The second piece, the post-processing, the treatment of black mass, that's a completely different market. And that's where there needs to be growth. And you've heard from a few different folks here. I'm heartened to see, you know, that we're all moving in that direction.
Yeah.
But that's what's missing. It's what's missing in Europe. It's what's missing in other parts of the world. China's a bit different. But yeah, anyways, just want to emphasize that point that there's two types of this market. There's pre-processing and post-processing.
Okay. Another very quick question for you from Wade Jagger while you're on. Are the batteries manually disassembled?
Sure answer, no. So we process from a module form factor forward. We do not discharge. We do not handle manually in earnest. And we're moving towards full pack processing without any manual intervention. So it's a big part of bringing down cost and trying to give that value back to the supply chain and to customers. So we're very attentive to that.
Yeah. Okay. A sort of general question. In fact, let me ask someone who hasn't spoken much. Benoit, are you there? Oh no, not unfortunately. Okay, Andrew. In terms of this challenge of reuse and recycle, given there's an ever growing intense focus on the circular economy, there's no doubt that reuse of things is going to start to be engineered into products, into energy storage devices. So are you confident that I've asked the